Aloha, here it is, crunch time AP Calculus. This is the last video of the reviews. These are the randoms. All right, so let's go ahead and take a look at it. So these guys are all going to be just really different. Like I say all the time in class, it is so important to make sure you pause and try these on your own. Okay, but here we go. Number 6. So number 6, so that means it's non-calculator, and this is from 2016. All right, we're given our table. All right, they tell us that f and g have continuous second derivatives. The table above gives values of the functions and their derivatives at selected values of x. Write an equation for the tangent line. All right, so we're going to do tangent line. We're doing it for k at y, x equals 3. So if it's for k, well, that means it's going to be y minus y1 or k minus k1 equals m x minus x1, right? And we know what x1 is. It is 3, okay? But we need to know what k1 is. Well, k1 would be k of 3, which would be f of g of 3. G of 3 is 6. F of 6 is 4. So my k1 would be 4. So here we go. Y minus 4 equals m x minus 3. All right, now if I find m, I'm done, and it's worth 3 points, you guys. Sweet. But let's go ahead and check it. So let's find. So you would have technically gotten 1 point for that. Okay, if for some reason you find the slope wrong, because the slope of k at x equals 3 would be the derivative of k at x equals 3. So let's find k prime of x, which happens to be a chain, which has an outside and an inside. The outside is f, so it'd be f prime. Don't you dare touch the inside. But then you have to take the derivative of the inside, which that has an inside, but the derivative of x is 1. Now we're going to, plug in a 3 to find the slope at x is equal to 3, which would be f prime of g of 3 times g prime of 3. Well, please excuse my dear Aunt Sally says I do g of 3 first, which is 6. So it'd be f prime of 6 times g prime of 3. Well, f prime of 6 would be 5 times g prime of 3 would be 2. So I get 10 as my answer. I plug that 10 in for that, and you would have got 2 points, okay, if you got that derivative right, and 1 point for plugging it all in and getting the equation of the tangent line. All right, but that's 3 already. Okay, so let's go ahead and find the next one, which is, so this is just, come on, let's get something like this in this year's exam. All right, we just got to find h prime of x, which is, quotient rule, which is the low times the derivative of the high minus the high times the derivative of the low, all over low, right? And then we're going to plug in a 1. So f of 1 is negative 6. G prime of 1 is 8. Hopefully I don't make a mistake here. G of 1 is 2. And then f prime of 1 is 3. I could easily make mistakes. I should probably be taking my time. F of 1 is negative 6, and I'm going to square it. So what's that? Negative 48 minus 6 all over 36. Is that all right? Sweet! Negative 54 over 36. Don't reduce. Just get the full credit. You guys, that's worth 3 points. So if you just did that correct, you got 2. And then you got 1 correct for plugging them all in. You should be 6 out of 6. Boy, let's please have one of these guys. All right, the last piece, right? It's got to be tougher, doesn't it? Well, it's an antiderivative now. Oh, yeah, definitely tougher. But we all know the antiderivative would just be f prime of 2x. But there's something on the inside. And since there's something on the inside, it means it's a little more complicated, and it means I should do a little u sub, right? And if I do that, I get this, right? We're all hopefully good at u sub by now. Spling and spling. Now that gives me equal to the 1/2 right here. I'm going to bring out front, and then I'm going to get f double prime of u du. Let's change my limits. So I'm going to plug a 1 in here. 2 times 1 is 2. I'm going to plug a 3 in there, and I'm going to get 6. Okay, now I'm going to take the antiderivative of this, and I'm going to come up here. I apologize. okay? And the antiderivative would just be f prime of u. I'm going to do that from 2 to 6. So then I'm going to be 1/2 f prime of 6 minus f prime of 2. Let me get you points so far. Okay, so the antiderivative, which would be this, would be worth 2 points. And now it's just answers. F prime of 6 would be 5. So it'd be 1/2 of 5. I'm sorry I'm all over the place, you guys. F prime of 2 would be -2. So that'd be plus. So I get 7/2 as my answer, which would get you the third point. So how about this problem? Huh? Just old school basics, right? Question A is just the chain rule. Question B is just the quotient rule. And question C is a little U sub. Bang, bang, choo, choo, train, 9 out of 9, right? All right, let's keep going. Number 6, this is from 2015. Let me hit pause when you guys hit pause and you try it. All right, hopefully you tried each piece or you're pausing each as we go along. All right, question A, write the equation of a tangent line. And at first look, this looks like a separating variables. But what's going to be interesting is, oh, is it a separating variables? Let's go ahead and find out. I don't actually think it is. It'd be y minus y1. Whoops, that'd be plus 1, equals m x minus x1. There's the -1. So it'd be y minus 1 equals m times x plus 1. All I have to do is find m, and m means you're going to find the derivative, and you're going to plug in a -1 for x and a 1 in for y, and you'll get 1/3 plus 1. So I get 1/4. Booyah, you're going to plug that in. How much would that be worth? All right, you get 1 point for getting 1/4, and you get 1 point for plugging it in. 2 out of 2. Okay, remember, hit pause, see how you're doing on your own, okay? B, find the coordinates of all the points on the curve at which the line tangent to the curve at that point is vertical. So that means we want to know where we would have vertical tangents. Well, I'm going to have a vertical tangent whenever the derivative is equal to d and e. It's going to be equal to d and e whenever the denominator is equal to 0. Now, we've solved some of these guys this year, right? We want to know when that guy is equal to 0. Well, there's a couple of ways of doing this. I think the best way is, hey, let's go ahead and solve for x. Let's get x by itself, boom, and then just plug that into the original. And that's going to give me some answers to work with, right? Now, what do I want you guys to do? Hit pause and see if you can get that right. All right, hopefully you guys tried it, right? All I got to do is plug that into the original, and you get 3y minus 3y squared times y is equal to 2, which if I do that, y to the third minus 3y to the third equals 2. Negative 2y to the third equals 2. If you solve that, you get y equals -1. Plug that into that guy, and you get the point 3 comma -1. And believe it or not, what do you get for that? If you just show that you set it the bottom equal to 0, you got 1. If you did this solving right, you got 1. And then you had to find the x value. Ooh, so how about that? That was worth 3 points. Now, the big bad boy, ooh, it's worth 4. 4 points if you're able to find the second derivative correctly, right? And that would, we just got done. We just got done doing a quotient rule, and this would be a quotient rule, which would be the low times the derivative of a high. Now, the important thing about this is the derivative of the high is 1, but I have to do it implicitly. So it'd be dy dx minus the high. Now I'm going to take the derivative of the low, which would be 6y dy dx minus 1 all over low. Now, if you were able to do that correctly, you get 2 bonus points right there. How about it? That's it. And then to get the other 2 points, they're asking me to plug a -1 in for x and a 1 in for y. Now, you guys, guess what? Since they're asking me to do that and I know what dy dx is, to get these 2 guys, I'm going to plug that. And I think, didn't we already do that? We already did that right in part 1, and we got 1/4. Right? If I plug the 1 in for y and a -1 in for x. So now I just have to plug and chug everything. So it's going to be 3 times y squared. So that'd be 3 minus -1, which would be +1. I've got a 1/4 there. Look at how sweet that is. Minus y is a 1 on the outside, and then 6 times 1 is that. Then I have a times a 1/4 minus a 1 all over. If I multiply the bottom, if I put a 1 in there, I get 3. If I put a negative 1 in there, 1, and then you square it. And if you do all of that correct, you get 1 over 32. All right, so you get 2 points for doing this whole quotient rule correct. You get 1 point if you knew to plug in a 1/4, sorry, for a negative 1 comma 1. And you get 1 point for getting 1 over 32. Okay, I don't know about you, but first two randos we did today, right? Maybe with randos, you would have expected them to be really difficult. But the random about these questions is they just are kind of questioning you guys about the whole year of AP Calculus. All right, I'm going to hit pause, challenge you guys to try this on your own. We just got two more to go. All right, I really, really hope you guys tried this thing. I'm going to make it a little bit of a bigger screen for me to work with. But we have a twice differentiable functions, f and g are defined by my table up there. They give me a whole bunch of everything. I know when I had you guys do these in class, I always wanted you to do a little sign analysis, okay? So for example, even before I do this problem, I'm going to do a little f prime sign analysis. And I have a critical point because f prime is 0 at -1 and at 1. And then what is it? It's negative here, then it's negative here, and then it's positive there. And then I'm going to do another one for g prime, and I bet you I'm going to have to use this. And the only critical point for that happens at 1. There's my critical point right there. That's it. It's all positives, and then that's negative. Okay. Question 8. Find the x-coordinate of each relative min of f from -2 to 3, and I have to justify my answer. So it's going to decrease, then it's going to decrease, and then it's going to increase. So that means 1 would be a minimum, right? So x equals 1 is a minimum, but you have to make sure you justify appropriately. And the justification would be x equals 1 is a minimum because, right, f prime of x changes, and I'll write this out for you, from negative to positive at that value, okay? And you know what? You can't say, hey, just look at my sign analysis, yo. You got to make sure you explain it appropriately. And guess what? That was only worth a point. Okay, here we go. Explain why there must be a value of C. Whenever we see this, this is 100 MVT. And remember, whenever it's MVT, you should always be since. Okay, since, what are we talking about here? F? Okay, so since F, ooh, that's F double prime, so that's the instantaneous. So this time is pretty interesting. We're going to use the mean value theorem, which usually is this, right? Your A rock is equal to my I rock, right? Usually that's what it is. However, they're giving me a little F double prime of C here. So the AP wanted to see if you could adjust, and that means these would just be F primes. Okay, so that's tricky part number 1 in this rando problem. But I'm still, right, what have I taught you to do? Whenever it's an MVT problem, write out the mean value theorem, and then you're just covered. And this one's worth 2 points. But I would probably write since F prime is continuous on the closed interval from -1 to 1, and differentiable on the open interval from -1 to 1. And how do I know this? It says it's twice differentiable. Okay, the MVT, and you want to state it, guarantees AC, A value C, such that F double prime, such that, right? We write down our little formula, which is this right here. So we're trying to show that F double prime is equal to 0. So I'm going to use this piece, right? And how would I do that? Well, that would be, and I'm sorry I'm up here, you guys, that'd be F prime of 1 minus F prime of -1, all over 1 minus -1. Well, F prime of 1, where's F prime of 1? F prime of 1 is 0. F prime of -1 is 0. Oh my gosh, 0 minus 0 all over 2 equals 0. Ching, ching, bing, bing, right? That means it works out. How about it? And there I just proved it. And what would that be worth? That'd be worth 2 points. And guess what? You would get all 2 points because you wrote out the mean value theorem. And I don't know about you, but in these reviews, we've done a lot of mean value theorem stuff. So you get that dude memorized. If you're struggling with it, you guys, make sure you come in for help, pretty please. All right, here we go. C, the function h is defined by this natural log of, looks like a chain rule. And how about it? It is a chain rule. They just asked me to find the derivative. All right, well, the derivative would be, the derivative of a natural log is 1 over. Don't you dare touch the inside, but then you have to take the derivative of the inside. I've got to do h prime of 3. My best guess is that's probably worth, holy snappy dappies, that's worth 2 points if you're just able to do that. And then you get 1 point if you're able to get this all correct. F prime of 3 goes upstairs. F prime of 3 is 1/2. That's upstairs over f of 3. What's f of 3? Just reading my table is 7. So I got 1 over 14. That would have been the third point. Okay, and once again, hopefully you're hitting pause and you're able to do these things because holy shamolies, look at D. That looks tough, but that looks like it has a lot of insides. Whenever it has insides, I beg you to do a little u sub, right? And if u equals g of x, that means du, the derivative of u is 1 du, but the derivative of g of x would just be g prime of x dx. So what do? What have I taught you to do in class? To get dx by itself and sub this and this into my problem. So I get the integral. It's going to be f prime of u because I'm going to plug a u in for g of x. But then look what happens here. You get a g prime of x, and then you get 1 over g prime of x du. Oh, spling, sweetie sweets. And then I just have to make sure I change my limits a -2. Oh, so it's going to be g of -2. Well, what's g of -2? Well, I'll fix that later. And then up here, it's going to be plug a 3 in for x, and that's just going to be g of 3. All right, so let's see if I have enough room here. Okay, so I get the integral. I'm going to do g of -2. What's g of -2? It's got to be in there. Oh, it's -1. It's right there in my table. What's g of 3? G of 3, what's g of 3? It's at the end. It's just 1. Okay, that wasn't bad. And then it's just f prime of u du. What's the antiderivative of f prime of u? Well, that's just f of u, and I'm going to evaluate that from -1 to 1. So that means it's f of 1 minus f of -1, right, class? And f of 1, that's probably just in the table. Sweet it is. It's just Niban. And then f prime of 1, that's probably in the table. That's 8. I get -6 as my answer. You get 2 points if you did all that antiderivative stuff correct. You get 1 point if you got that answer of -6 correct. All right, here we go. Give me them toes. We just got one problem to go. Last one here of our review, so hit the pause and really try it. Here we go. All right, here we go. We've got a crazy area. It looks like I'm going to have to go a page ahead to make it bigger so I can look at it. Okay. All right, so we have a figure above. It's a graph of f prime. Remember, that's very important to make sure you pay attention to. It's twice differentiable on the closed intervals. Maybe they'll ask us about a mean value theorem. I don't know. Let's keep going. The graph of f prime has horizontal tangents at 1, 3, and 5. Now, how do I know they're at 1, they're at 3, and they're 5? Because there's horizontal tangents. Now, they say that f prime has horizontal tangents. It's important to make sure you pay attention to. The areas of the areas between the graphs are labeled in the figure. The function f is defined, and they give me an initial value. And it doesn't start at 0, it starts at 8, so that could be a little bit tricky. Okay, find all values of x on the interval for which f has a local min. Now remember, I ask you guys every time we do these to do a sign analysis. Okay, and they're asking us about f, so we're going to look at f prime. Well, this is f prime. Well, what goes on my sign analysis when f prime is 0 or DNE? And it's 0 at 1, it's 0 at 4, and it's 0 at 6. And the graph is above, above, below, above. So it's going to increase, increase, then decrease, then increase. So it looks like I have a minimum at x equals 6. And it actually, because I have to check endpoints, ooh, no, I don't have to check endpoints. Okay, but if it did include x equals 0 would have been a minimum. But I'm going to say x equals 6 is a minimum. Why? Because f prime changes. Make sure you write it down. F prime changes from negative to positive at x equals 6. Okay, and that was just worth, how about it? That was only worth a point. All right, the next question though says to describe the absolute minimum value. Oh, I just gave a hint, right? Absolute minimum value. So it would be at 0 or at 6, right? I've got to check both of those. When it says to justify your answer, all right, this is where it's going to get a little tough because I have x and I need to know what f of x is. And I've got to check 0. I got to check my endpoints, which are 0 and 8. And I also have to check 6. Well, how the heck do I do this? Well, do I know what f of 0 is equal to? Well, they give me an initial value. So that means I got to use it. So it's going to be equal to f of 8 plus, I got to get to 0. Well, the only way to get to 0 using f prime would be find the antiderivative from 8 to 0, right, class, of f prime of x dx. Now remember, these are backwards. And whenever it's backwards, I've told you, right, if I just rewrite what it's equal to, I'm going to do the opposite and I'm going to flip it. Now, why do I want to do that? Because I'm looking at a picture. Now, f of 8, and I'm sorry, I'm going above here, is equal to 4. And then I'm going to take the negative of all this, but this would be what? 2? 2 plus that would be 8. That's negative 3. So now I'm at 5, and then that would be 12. So it'd be 4 minus 12. And if I do all that correctly, I get an answer of negative 8. So it'd be 0. F of 0 would be equal to negative 8. I'm going to circle it so I have it. But I also have to find f of 6. Well, what's f of 6? Well, it'd be f of 8, right? It'd be f of 8 plus, I'm going to go from 8 to 6 of f prime of x dx. Now, I apologize, but I'm going to have to come down here. I'm going to go f of 8 into my face, but I got to flip them, okay? What does that give me here? F of 8 was 4 minus from 6 to 8. Where's 6? 6 right here. 6 to 8 would be 7, so it'd be 4 minus 7, which would be negative 3. So far, this is the absolute minimum value is negative 8. And then, oh, sweet, F of 8 they give me, that's just foul. So then that's easily the answer. Boy, was that a lot to take in. And that would be, and make sure you say that absolute minimum value is negative 8, and it happens at f of 0. But that was worth 3 points. That was worth 3 points. You got a point for considering 0 and 6 as the possibilities. You got 1 point for your answer. And then remember, whenever it says justify, they want to see a table. So you got 1 point for the table. Okay, here we go. C, on what open intervals is f concave down and increasing? Well, the increasing comes from the first derivative. So I'm going to redo my sign analysis, right? It's 0 at 1, it's 0 at 4, and it's 0 at 6. And then it goes what? Pos, negative, positive. So it increases here, it increases here, it decreases here, and it increases here. All right, concave down means we're going to look at the second derivative. Well, to look at the second derivative, I want to put the critical points, which would be when the slopes are 0. And they already told us that the slopes are 0 at 1, at 3, and at 5. And then let's look at the slopes, right? Because this is f prime, f double prime, the derivative of that would be the slopes, which would be negative, then positive, then negative, then positive. And they're asking where the second derivative is negative, concave down, concave up, concave down, concave up. So where is it concave down and increasing? So it's concave down and increasing from 0 to 1, it looks like, right? 0 to 1. Where else would it be concave down? From 3 to 5, but it's got to be increasing. And it does increase from 3 to 4, so that'd be union 3 to 4. Okay, and you make sure you just give the appropriate reason why. And the appropriate reason why is because the first derivative is positive and the second derivative is negative. Okay, or you can even describe the slopes if you wanted to. But that was worth 2 points. And then last but not least is part D. And part D was worth 3 points. So you could have struggled with that stuff and still gotten the 3 points here for part D, because D defines a brand new function for us. They give us an initial value and they ask us to find the slope of G. Well, the slope of G would be the derivative of G. And how about that? That's a chain rule where your inside is f of x, but your outside is the power of 3, which is a power rule. Don't you dare touch the inside, take away 1, but then you have to take the derivative of that inside. Okay, and then we're going to do g prime of 3. Oh my gosh, this is actually way more okay than I ever thought it could be. Okay, f prime of 3. All right, well, let's do, please excuse my dear Aunt Sally, f of 3. Oh, sweet, they give it to us. Could it really be that simple? F prime of 3 is just what is the graph at 1, 2, 3, and it's 4. Okay, and it's multiply. Oh my gosh, are you serious? So it's 3, it's 25 over 4, but the 4's cancel out, spling, spling, and you get 75 as your answer. You get 2 points. just for that, and you get 1 point for getting 75. Now, I really hope you guys tried all these on your own. Please watch old videos. Any topic that you guys are struggling with, please watch old videos. Students in the past always say, hey, I just use my website. Remember, you guys all have access to this. I've got all kind of review questions down here. If you're struggling with a video, just try it, you guys, and that's how you will dominate. Come in for extra help, please. Aloha. Good luck. Destroy it.